Hi, welcome back to Trigonometry. Hey, this is a good one. This is navigation. As you can see, we've got a couple of army dudes here in dense forest or Australian scrubland by the looks of things there, and they are trying to get their bearings and the sighting of distant objects and so on so that they can head off in the right direction. Now, might be using a compass like this guy, or we could be using GPS systems, but GPS systems, global positioning satellites, aren't always accessible to us. So let's have a look at how emergency people and people in dense scrubland and that actually can get out of there and head off to the town or wherever they're wanting to go. I think it's often called, have you got your bearings? And this is the area of mathematics we're going to look at now in relation to trigonometry. A bearing is a heading or a direction you'll go in. So there are two types of bearings. It's called true bearings, where we face north, and here we are. This is the usual way we designate north, south, east and west, the 4 points of the compass. And the idea here, if we're trying to indicate to somebody how to get to town A, we face north and say, hey, you should turn 36 degrees clockwise. So this system uses a face north approach and turn clockwise. Okay, so it's written like this. What's the other way of doing it? It's called compass bearings, where you give the same idea of turning, but you start at north or south, whichever one's closest. So here, if we were going to this point here, we would face south because north is too far away. So we face south and then tell people to turn back towards the east by that amount, 45 degrees. So the bearing statement is south 45 degrees east. So that's called a compass bearing, and if you were doing it with the other system here, true north, you always face north and turn, so this would be 135 degrees true. So that's a little bit different there now, those two systems. So I'd like you to get familiar with those two and see what you think, because both are used in the real world, and particularly for navigation and things like that. So that's important to remember. All right, let's come down. There's some exciting applications in this set. So come down and we'll have a look at the first couple of problems, getting used to the idea of bearings. So let's have a look at trying to write this one over here as a compass bearing. So you can see we're headed to B from A. So we're going to face south because it's closer to south and turn 58 degrees to the east. So here are the steps. Look to the south or the north depending on which one's closer. Here B is closer to the southerly direction, and you're going to turn towards the east. So put that and then the number of degrees. What about true bearings here? Right, you face north, always turn clockwise. So we have to work out this angle here. So it's going to be 180, take 58 down the bottom here, which is 122 degrees true. So you could read those steps there from Pearson's, go through those regularly each time. What about up here, what about the compass bearing for this one? Well, you can see B this time is closer to north. So we're going to face north. We have to turn to the west. Remember, this is east, this is west. We've got to turn to the west this amount. We're actually going to have to work that out. It's 90, take 13, is 77 degrees of turning to the west. So we explain it that way. Face north, turn 77 degrees to the west. And what about the true north, the true bearing one? We've got to turn right around here, because true is always facing north and then turning clockwise, no matter how far it is. So how far is it? It's around 270, 3 lots of 90, plus that bit there. So it's 270 plus 13, 283 degrees true. By this time, you might be asking, well, how would I measure these degrees if I was out there. Well, there's such a thing as a compass. It's housed in a little box like this with a glass cover, and the spindle here holds a magnetised needle, and because of the Earth's magnetic field, this will point north, and then you can set your number of degrees away from it. So it's got a scale around there as it points a bit off centre there. Let's get rid of that. Here it's in the centre and it's pointing here, and this is all scaled around the outside, so you can actually measure degrees. Alright, let's have a look at this one. A yacht sails on a true bearing of 215 degrees true. That means face north and come around here. How far south is the yacht from its original position? So if it sails off on that bearing, there we go, 64 degrees, it's obviously going partially south. So form the triangle. This would be, what, 180 or 215, take 180 to get that angle in there of 35, making up a little right angle triangle here. So you could pull this over here and have 35, don't know that, 64, and then go to the angle, look out, no, we don't have the opposite, go to the hypotenuse, look out, go to the 90, look out, it's hypotenuse, and of course the adjacent is the thing we're trying to find. Let's list it. Angle, hypotenuse, adjacent, so it's cosine. Why? Let's check it with SOHCAHTOA. Yep, we've got adjacent and hypotenuse, so we've got this one, cos of 35. Remember, x has been divided by 64, we'll reverse it, times by 64. Then to get x back again, we have to work that out on the calculator. So then answering the question, how far south is it? Can't have x. We introduce that as young mathematicians to solve the problem. We have to give the answer as the people asked in the context of the question. The yacht is 52.43 kilometres south from its original position. Okay, starting to get into a bit of a pattern here, a problem-solving pattern. I hope you can remember that. Let's go down and practice it again. Here's another one. So let's have a look. On a hiking trip, Sarah walks 8.3 kilometres west and then 5.4 kilometres north. Let's draw the diagram. Remember here, north, south, east, west. So she's going west, there it is, and then 5.5 north. There's a 90 there, because between all of these points of the compass, 90 degrees. Calculate a true bearing and compass bearing from the original position. True bearing is right around here, so we must go off and find theta. Let's draw the diagram. So that's theta, 8.3k, 5.4. Go to the angle, look out, that's the opposite. Go to the 90, that's the hypotenuse. So the last one is the adjacent. What have we got? Got opposite, the adjacent, don't know theta. SOHCAHTOA to the rescue. We have opposite and adjacent. TOA, there, the last two. So it's a tangent. And to find the angle, we come back from the tangent. The inverse tan, we've got 33 degrees. So the true bearing is 270 around to there, plus 33. 303 degrees. Now if we're going to do a compass bearing, it's closest to north, so we go north and we want this angle. So this angle is 90 minus 33, which is 57. So we go north, face north, swing 57 degrees west to return her, or to give the original position. All right. So we would know where to go to find her, wouldn't we? If we're starting at a starting point, we could go off on that bearing and using either system and find her. exciting stuff. What I'd like you to do now is to come down and have a look at Pearson's Problems here. Here's the first question through to F. So doing it in two ways. So pause the presentation now, have a go. I'll go on and just bring up a few more here, down to question 4. Just putting those on there. Okay, somewhere about there. For A and B. For 4, pause it, have a go. Make sure a diagram and careful listing of the information and labelling the diagram is important. Okay, come down, understanding problem, a bit harder here. So number 5, 6 and 7, remember a diagram. And you might use compass bearings on your sheet to remind you they're all at 90 and they are the directions we use. So here is a bit of a harder question, 8, 9 and 10. Look at the warning. Only round the final answer. As you work through a problem, you might have to go from one triangle to another. Don't round it off. You'll lose accuracy each time. So if you want 3 significant figures, use 4. If you want 2 decimal places, use 3 decimal places. So again, a diagram and the compass bearings are extremely important. You might try a few of these if you've got time. Try all of them. And then the reasoning problems. There's a compass I was trying to draw before. Have a look at that one. Here's a hint. Just because you're doing trigonometry doesn't mean you can't also use a bit of Pythagoras first. Okay, because if you have a 90 degrees anywhere, just keep in mind, probably the quickest way of finding a side, if you know these two, is not trigonometry but by Pythagoras. Okay, so remember that. The square on the hypotenuse equals the sum of the squares on the other two sides for Pythagoras. So you can always use that. Alright, so quite a bit to do there. Coming down, and of course there's some open-ended ones at the end there. I'll just leave it, I think we just go here so you can pause the presentation and see what you can make of those. Okay, are you feeling that you're getting some real power here? You're actually getting to be able to use trigonometry in a very useful way. So get excited about it. I think there's a couple more presentations leading on to the same idea. How can we reach a high level of understanding so that we can actually use this very practically? All right. Well, we're going well. Keep up the good work. Work hard. Practice. And I'll catch you in the next presentation. It's cheers for now.